Okay, so continuing projectile motion, today we are going to discuss about projection from tower. So we'll take few different cases, like if you have to throw some particle or object from tower in upward direction. In second case, we'll talk about if you throw any object in horizontal direction, and in third case, we'll talk about if you throw any object in downward direction. And what cases we can consider and how to proceed with the solutions and all. See, suppose first case will be suppose uh, this is ground, this is ground, and here is the tower. Suppose h is the height of the tower, and from here, from the top of the tower, you throw a ball in horizontal direction, completely in horizontal direction, parallel to the earth, ground, with some initial velocity or speed u. Now you know that because gravity will always keep on working on the ball, so it will follow this path and it will come down like this. It will follow this path, right? So this is also a parabolic path. So this is also uh, a case of projectile motion. Now, so first thing you know that we have to draw the chart. Suppose this is your x-axis, and upward we can take y-axis. You can take plus y-axis in downward direction as well. It won't affect. So x, like horizontal component, let's call it x-axis as horizontal component, and this is vertical component. So we are considering right side plus, upside plus. Now, what is the initial velocity? What is the horizontal component of initial velocity? That is u only, because ball was projected initially in horizontal direction only. And what is the vertical component? Means along y-axis of initial velocity. That is 0. There is no component in vertical direction initially. And what is acceleration along x-axis? No acceleration, because there is no external force acting along the x-axis. Only one force that is acting is gravity, and that always keeps on acting in downward direction, negative y direction, right? And ay is, because we have taken downward as negative, so we'll take g as acceleration is negative. So at any time, and what is this? Okay, so at any time, if you see, you know that because in horizontal direction there is no external force working, so it won't affect, and there is no acceleration, so it won't affect the horizontal component of the velocity. So at any time you can apply the formula v equal to u plus at. So we are talking about x direction, horizontal direction, x component. So vx will be ux plus ax into t. So ux is u and acceleration is 0. So this complete whole thing will be 0. So you can now see that Vx is also u. So whatever we had the initial component of the like the horizontal component of the initial velocity, it will remain same throughout the journey because there is no acceleration along x-axis. Understood? Because if there is no acceleration, there is no force. And if there is no force, then there should not be any change in the speed. And if you talk about along y-axis, so you can apply this formula Vy equal to Uy plus Ay into T. Vy initially it is 0 and Ay is minus G or into T. So Vy is changing. If you want to find, suppose at any point, you can find displacement along x-axis and along y-axis. So displacement is what? Displacement along x-axis is ut plus half at square. So u is u, t is t, and there is no acceleration, so it will be 0. So displacement along x-axis, that is, let's say x. So at any point you can find xy. So this is the displacement along x, and this is the displacement This is the displacement along y. It will be the displacement. This is y because now we are taking xy from here because we have origin over here, na? Origin at the top of the tower. Understood? So, and what would be y? Y you can write as displacement along y-axis is uy into t plus half gy into, sorry, ay into t square. And we have taken upside as positive, so displacement is minus y. And ui is 0 because there is no initial vertical component. And this is minus half g into t square. So you can see that y equal to half g t square. So you can see that on this path, suppose there is like there is a random point whose coordinate is x comma y. So you can also relate these coordinates x and y. How? See, from here you can see that t can be written as x upon u, and here you can put half g t square, that is x upon u whole square. So y equal to g upon 2 is u square x square. This is very good result. X square equal to 2u square upon g into u into y. So this is the path. Equation of trajectory. This is also parabolic, na? Understood? So if you throw any, I mean, there is no need to remember this formula because if you understand the mechanism behind it, you can always derive it within a minute. Note it down.
Yes, sir.
Noted or still going on. Done, Archit and Ayushi.
Yes, sir.
Okay, let's move ahead. Now, okay, fine. So in this case, what we have to do is, I'm talking about case one only. So here is this is your target. Sorry, this is your tower, and this is the ground. So from here, suppose we have thrown some object with some initial speed u in horizontal direction. So we have taken this direction as x-axis and this direction as y-axis. So it will follow this path and come all the way to ground like this, right? It will hit over here. So this is the height of the tower. So the horizontal displacement that it covered is known as a range, right? And the total time taken from here until ground is known as time of flight. So we have to find, and suppose like it will when it will strike the ground, so we have to find the speed as well. So what would be the speed with which this object will strike the ground and at what angle with the horizontal as well. So all these things like parameters we have to calculate. Okay, now see, to find the time of flight, what we'll apply? We'll apply the this formula, displacement equal to ut plus half at squared. And because it will come down, it will cover this displacement along y-axis, right? As displacements. So let's talk about the displacement along y-axis only. So sy equal to uy equal to ay. Sy is, so we have taken y as positive in upward direction. So in downward direction, it would be negative. So displacement would be h downward direction. So displacement would be minus h. And there is no initial, there is no vertical component of the initial velocity. So this y is 0. So the 0 plus half. And acceleration along y-axis, that is minus 0 always. T squared. And let's call this T is time of flight. That is T. So total time taken from here to here. Minus minus gone. So you can see that time of flight would be 2h by g. This is similar. This is same as when when you release a object from some certain height h. So in that case also it takes the same amount of time under root 2h by g to reach the ground. And what about the range? Range you can simply find out initial velocity into total time taken, because we know that there is no change in the uh, velocity in x direction because there is no external force, there is no acceleration. So u into total time of flight will give you this horizontal displacement. So u is u, and this is your. All right. Now we have to find. So, and you can find speed at any moment. Simply at any moment it will have two. Like this is the speed, suppose it will have two components, Vx that is equal to u, and this is Vy. You can easily calculate. How? That is minus simple half gt squared. And you can find this speed at any moment, v equal to under root Vx squared plus Vy squared. You can simply put here Vx and Vy, you will get this speed at any time. And suppose we have to find the speed with which this object will strike the ground and at what angle with the horizontal. So here, suppose v is the velocity of the ball when it strikes the ground. So it will have two components, Vx and Vy. Vx, you know that it will remain same as initial velocity u, horizontal direction. And Vy would be uy, that is 0 plus at, that is minus z into total time of flight, capital T. So this is minus g into under root 2h by g. So this is your under root minus 2g h. So negative sign just indicates that the velocity is in downward direction. So at any moment you can find that under root speed is under root vx squared plus vy squared. So this is u square plus 2g h. You can see that v square equal to u square plus 2as. A is minus z, s displacement is minus s. So you same thing you got from it. You can also without doing all these things, if you can simply apply v square equal to u square plus 2s, you will get the same result. And this angle you have to find. So just you can use vector addition. So this tan phi would be this vector. So if this is vy, so this will be vy upon vx, vy upon vx. So vy is under root 2gh and vy is u. So at this angle, like now, phi is tan inverse under root 2gh upon u. Understood? At this angle, it will strike the ground. Tell me if you understood or not. Note it down.
Done, sir.
Archit हो गया. Archit done.
Yes, sir. Done.
Okay. Now second case will take case number 2. When you throw any object from tower at some angle with the horizontal line. This is ground. This is tower having height h. And now in this case, we are not throwing this object in horizontal direction. We are throwing at some angle with the horizontal. Suppose use the initial velocity. With some angle theta, we are throwing. Now everything will remain same. You just have to like analyze the or you can make the chart as well, but like enough times, like we can multiple times we have already made chart. So right now, like we are not making it. We can simply think. See, so this initial velocity has two components. So one will be along x-axis and one will be along y-axis. So let's assume this is positive x-axis and this is positive y-axis. Now you can see that. So what it will do, like we have thrown in upward direction, so it will follow this path like this, like this, like this, like this. It will go down and strike the ground somewhere here. So this complete path it will follow and then it will strike the ground. So suppose if you see like from here to here, it's like a parabola, like complete ground to ground parabola. So suppose like I want to find the total time of flight. Find time of flight. It means that time taken in complete journey from here to here. So you can simply find time of flight like what is the net displacement along y-axis minus h, na? Because you have thrown this in upward direction, it will come down over here. So from here to here, there is no displacement along y-axis. So from here to here, displacement along y-axis will increase, and from here to here, it will decrease, and from here to where it is minus h. So simple, displacement along y-axis minus h equal to what is the initial, like what is the vertical component of initial velocity? That is u sine theta. In this case, we have u sine theta, but that is in positive direction. So u sine theta into time of flight and minus half, and acceleration is g into t square. You can solve it from here, right? Time of flight you can easily get. Understood? You can find, you can solve the quadratic, whatever, like and that is very easy. Second thing you can find is find maximum height from the ground. So from the ground, see, from the ground means maximum height. This height, that is already we have h and plus this height. So for this height, you can simply find like from here to here. This is like ground to ground projection, like projectile motion. So you're gonna simply find as h plus this height. This height is right for this. So we can find like for this, what is the maximum height? That is u squared sine square theta upon 2g. So h plus this is the maximum height of this from ground. Understood or not?
Understood.
Are you see?
Yes, sir. Hello.
And yeah. And what could be the range? Let's
Sir,
say
I
this
have a
is your
doubt.
tell me.
Sir, in time of flight, how does sine theta cancel out?
No, it will not cancel out. You have to you have to solve it as a quadratic equation. It will. There is a quadratic in T, na? How do you solve? How do you find roots of quadratic equation? Minus b plus minus under root b square minus 4ac upon 2a, na? You see. See, it will be like just cross multiply by 2 and bring all the terms to the left side. So it is like gt squared minus 2u sine theta into t and minus 2h equal to 0. So now t can be written as minus b plus minus under root b squared minus 4ac minus plus 4g h upon 2, like this. You have to ignore negative sign because this is 2u sine theta and this is 2u sine theta plus something. So if you take negative sign, so this term will become greater than 2u sine theta. So you will get time as negative. That is not possible. So we'll not take negative sign, we'll take positive sign only. And for range, this is the
Okay,
range.
sir.
What is the range? There is no acceleration along x-axis. So you know that this horizontal component of the initial velocity will always remain constant. So the range would be initial velocity or into total time of flight And whatever time of flight you will get from here, just put here, you will get the range. Understood?
Yes.
And
sir.
same thing, everything you have to do same thing. I'm not repeating like each and everything again and again. And even I'm not talking about the case 3 because the case 3 is so simple. Na? I'll just give you a hint and the rest we'll discuss in question only. We'll take good question.
Done, sir.
Let me give you some of the questions from Erodo.
Sir, you're not audible.
Can you hear me now?
Yes, sir.
I'm telling you that let me take some questions from Erodo.
Okay, sir.
I haven't talked about the third case, like when you throw the ball in downward direction. Same, everything will be same, and this direction will be opposite. Try this question. Do you think that you will do it? You can do it. I mean, did you understand the question?
Yes, sir.
Guys, taking too much time. Let me explain you. See, question says that a cannon and a target are this much kilometer apart. So it simply means that this is your ground, this is the ground, and suppose here cannon is located, and this is cannon. This is not cannon. This is cannon, and here is your target. It says that, like and the distance separation between cannon and target is 5.1 kilometer. Okay, and at same level. So you can simply consider ground to ground. How soon will the shell launched with the initial velocity 2? So from this cannon, if a shell is launched with some initial speed, 240 meter per second. So it will again follow the same path and like this, it will come and hit the target, right? And there is no air drag or anything. So definitely it will be at some angle with the horizontal. So you have to find how soon. So it's basically what? Time of flight. It's basically time of flight. So how much time it will take to come from here to here. So it is very simple. P equal to 2u sine theta upon g. But you do not have sine theta. So time of flight. So okay, fine. But you do not have sine theta. Na? So do one more thing. This is also given. Na? We also have to use this data. So this is a range actually. So range is what? This is range is what? What is the formula of range? That is u squared sine 2 theta. Or no, don't do that actually. Don't do that. Do
Sir, can I say something?
wait. This is u cos theta, and this is u sine theta. So you can simply write range as u cos theta into time of flight. So from here you can see you can get sine theta, that is gt upon 2u, and from here you can get cos theta, that is r upon u t. Just you have to eliminate theta. So square 1 plus square second equation. Square both the equations and add. So sin square theta plus cos square theta, that is 1, equal to g, that is 10 t upon 2 into u is 240 whole square, plus r is 5.1 uh, kilometer. Okay. So and u is in meter per second. So you have to make this into meter. 1000 multiplied by this. So 5100 meter. So this is 5100 meter upon ut. U is 200 and t whole square. You can solve this and find t. That's it. You have to solve it. Right. So answer is already given. You can find. Note it down. Now I see. You can say if you want to say.
Sir, I was saying, what if we say, so if we can imagine a projectile from the cannon to the target, they are both at the same level. Then we can imagine at the highest point the ball will come, and then that can be the height h, and that will come from the. Sir, should I send you a picture of this?
No,
What I've done.
you are saying that if you consider what?
So if we consider that at the highest point the canal ball will be there, and then from the highest point it will reach the target, and then the range will be 5.10 kilometer by divided by 2.
Then why you divided into two parts? That is
Yes, and
also
then
correct. So you can consider from
but
ground to highest point and then highest point to ground again. Then why don't you consider the whole thing like as like one phenomena? Hey, why are you dividing this into two different situations? Why?
okay, sir.
So from cannon to target, you can see this is the complete journey. So time taken in this complete journey will be total time of flight, and it is at the same level. So it is ground to ground projectile motion. So you can simply apply the formula of time of flight to u sin theta upon g, and range for that you can apply u cos theta into time of flight, and from there you can eliminate theta by using identity, and you will get the answer. Right?
Okay,
Don't
sir.
solve it right now.
Yes.
You can solve it later, and you have to match the answer. Note it down. Done. Shall I give you second question?
Sir, just 1 minute.
Archit, did you understand this complete thing?
Yes, sir.
Done, sir.
Now let's take second question. This is a very good question. I know that, like, I what I want is, like, you guys just go through the questions and tell me what you understand from this question. I'll solve it. Just go through the question and tell me what you understood. Giving you only 2 minutes, not more than that.
Sir, this was a homework also, right?
Sorry. Sorry,
Sir,
come
this was
again.
a homework also, right? Sir, we had this as a homework also.
When I gave that?
Yes, sir.
Okay, I don't remember. Okay, but let me solve it. See, uh, what this question is saying. So it cannot fire successively. So one after another. Two shells with velocity same. The first at an angle theta 1, 60 degree, and the second at an angle 45 degree to the horizontal. There is no external force. So you have to find the time interval between firings leading to the collision of the cells. So the question says that, suppose from here, two shells are firing, one at some angle, suppose 60 degree, it will it will follow this path somewhere, and another cannon at some angle 45 degree, 45 degree, and it will follow some different path, and it is saying that somewhere it will collide in the air. Same thing, it is saying that somewhere in the air it will collide. So it is saying that, what is the time interval between the firings, firing, right? So what we will do is, so see, at this point we can see that these two cells are colliding. It means that at this point, at this moment, both the balls will have same x displacement and same y displacement, isn't it? So both the shell will have same x and y displacement. Suppose shell 1 will takes like some t1 time to come from here to here, and shell 2 takes t2 time to come from here to here. Suppose if we find t1 and t2, then what is the difference in their time, firing time? We can simply do t1 minus difference of those time, right? So let's find t1 and t2. So we can see there are two things that we can use, because they are colliding in the air, so they must have x and y displacement same, because shells are colliding in the air, so they must have their x and y displacement same, right? So x displacement of first shell must be equal to x displacement of second shell, and y displacement of first shell must be equal to y displacement of second shell. Let's solve it. What is the x displacement of first shell? That is, first means 60-degree one, right? So x displacement is what? V naught cos 60-degree into T1 must be equal to x displacement of second shell. So what is the initial component, horizontal component of initial velocity? That is V naught cos 45-degree into T2. Tell me, you understood or not?
Yes, sir.
Archit,
Yes, sir.
this V naught go, cos 60 is half. This is T1 equal to 1 by root 2 T2. Cancel. So T1 is root 2 times T2. Now equate y displacement. So what is the y displacement of first object? That is uy plus half ayt square. So now in this, for vertical displacement, we will consider vertical component of the initial velocity, that is v naught sine 60-degree into t1 minus half g t1 square equal to, for second shell, it is v naught sine 45-degree into t2 minus half g into t2 square. We'll solve it. So what is the value of v naught? Okay, do one thing. Bring this to this side. So v naught cancel. Sine 30 is root 3 by 2 t1, and this is 1 by root 2 t2, and this will go that side. So g by 2 is 5, 10 by 2, 10 by 2. So 5 will be out. T1 square minus T2 square. We have to now solve it. See, the value of v naught is 250 meter per second. This is 250 meter per second, and root 3 by 2. And what is the value of T1? That is root 2 T2. Root 2 T2 minus 1 by root 2 T2. And this is 5. T1 is root 2 T2. So square of that is 2 T2 square minus T2 square. This is root 2. So 250 multiplied by root 3 by root 2 minus 1 by root 2. That is root 3 minus 1 by root 2 into T2. And this is 5 into T2 square. 1 T2, 1 T2 cancel. So 5 and 50. And so this T2 is 50 into root 3 minus 1 upon root 2. So you will get T2 here. Put here, you will get T1. That is root 2 into T2. 50 root 3 minus 1 upon root 2. This is gone. So this item is bigger than T1. So the difference in time is T1 minus T2. So this will be the difference in their firing time. Did you understand that?
Yes, sir.
Note it down. Later you can solve it at your home and you can match the answer. If it does not match, let me know.
Sir, sir, I did it the same way and I got 10.712
That is fine.
seconds.
Very much like close. That is very much close. Don't worry.
Done, sir.
Archit, done?
Yes, sir, done.
So in next class, I'll take projectile motion on inclined plane. Right. So note this down. Today I'm damn tired, so I'm just stopping class here only. Okay.
Yes, sir.
Okay. See you tomorrow. Tomorrow at same time we'll have math. Bye.
Thank you, sir. Bye, sir.
Thank you.